Hello, hi. I need to shade my eyes. I need these shades, cool shades. Shade, she knows how to use them. But then, I'm back. Serious, serious stuff. Chemical engineering experiment. And three amino acids. Glutamine, arginine, lysine. And I have the catalyst, chromium picolinate. And 500 milligrams, so only the so this is not going to be a first order and a second order reaction. It's just going to be a first order reaction, which is but it's a little different. A plus B. So we have there in my previous experiment, micropipette assay experiment, B was not reacting at all. It was preventing back reaction, but then, I found out after I did the kinetics, and I have asked you to more like Google, the CEO of Google, to attach all my results, my worked out results, and I found that for the second order reaction, and it was in conformation with conform concordance with the simulation I ran for the first order and second order reactions. That for twice the amount, the second order reaction, I had to have taken twice the amount of ascorbate. So it just went on. It went on to melanin. The reaction. It didn't stop at L-DOPA. All right, so there, and anyway, so this is the second B. So I'm hoping potassium bitartrate combines with these amino acids, each of them. And here are the structures of the amino acids. Amino acids. So here are the structures. So that there's a lot on the properties in this book. I have shown you this book, but the interesting fact about these three amino acids, and it's pure coincidence. I've just picked up these amino acids. So go to your local health food store if you're an avid researcher, and you're going to find some ways of getting the right blend and right reactants. So this is lysine. So I have a CH2. So that's just 4 times. CH2 4 times, glutamine, CH2 twice, and then arginine, CH2 thrice. So this is twice, this is thrice, and this is 4 times. So which means what is happening is what I'm interested to see. Will there be contribution by the methylene groups, and will the reaction rate, I'm going to be observing each of it. There might be a fraction measurement a little bit, but then it's going to carry over to all the three, a little bit of overlap that's going to carry over to all the three, because there's going to be an equivalent time delay. So here goes. I'm going to begin like the last time. Like the last time, I have 30 ml of water in each of these micropipette tray compartments. And I'm going to begin the reaction and start the reaction and then set the timer. All right, so this will begin with this is a little hard. So I'm going to take a half a tablespoon because cream of tartar, potassium bitartrate. I thought I would take tartaric acid, but it's the brown color. It's going to mask any possible color change, anything. I was just joking. Somebody is in real pain, all right? I mean, exposed to coal, heater shut down, really strange circumstances, really hard luck story, and quite dark. And I don't know the gentleman, but he's given me words of encouragement throughout my writing, because somehow he on the internet and everything, so YouTube videos, and thinking cold for because the cold, the heaters were down to 69 or something, or 65, 69. So Can't tell frostbitten, a little bit of frostbite. So suddenly, I'm getting these distress signals. How am I going to say that he's frostbitten, right? I mean, you can say on mine, I'm brown. My hands are darker than my the rest of my body. All right, so half, uh, or we do, okay. This I best is to pour this in to a cup. Pour this into a bowl and then put 500 milligrams is so cream of tartar comes in handy in candy making. Tastiest of candies. Mm. Otherwise, or vessels are cooking, you don't want to add tartaric acid, then you can add cream of tartar. Okay, so uh-huh. And I'm just looking for non-toxic things, because the labels I hear because I published, I made HCN, accidentally in an undocumented reaction. So I hear jokingly somebody lets slip joke that they joke that something could happen to them. So I'm careful. So food engineering is one of the best areas. Although I didn't personally work. I worked with phenol and I was pregnant and my supervisor then was a good man. No Dr. Jekyll, Mr. Hyde. He even got me a respirator. So I never even breathed the phenol fumes, that sort of thing. And all under the fume hood, under the greenwood tree. So all right, so I'll begin. So half a teaspoon, or a quarter teaspoon, 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 quarter teaspoon. I think I need a bit of refill. Quarter teaspoon, or what's that? Quarter teaspoon. Right measurement. Quarter teaspoon. So there's quarter teaspoon in there, and then in each of these compartments of the micropipette. Quarter teaspoon in each, quarter plus quarter teaspoon of cream of tartar or potassium bitartrate. Okay, so let's start the reaction by adding each of the amino acids. So I begin with glutamine. It doesn't start till so each of these glutamine, 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 glutamine. Oh, this is arginine. I need a different teaspoon, I think, right? I would be needing a different teaspoon because then it will not contaminate the results. 2, 3, 4, and 5. So that's it. So once I add the enzyme, I'm going to get 2 more teaspoons. Okay, 2 more teaspoons. So 2 more teaspoons. Where's the teaspoon? This teaspoon. We're going to start the reaction. Adding the catalyst. No, please, catalyst is 1 container. 1 container. So beginning, so I will add one and start the reaction, or just, still stirring is done. There's no reaction. There's no reaction. Still stir. So now reaction is starting. So stir, beginning stirring. So I am going to stir all of these. That was easy, wasn't it? First order, second order. This is hard. Okay, we're going to let this go. So TT equals 0 sample. I'm not taking. Stir. Get right results. Stir. But then you know what? The reaction could be so successful. You could make HCN. So what am I making? Potassium tartrate. Simpsons. Potassium tartrate. Maybe this is the next. It's settling down. Okay. All right. We'll just do this. Stir. So we will So capsules are, as I pointed out before, and you probably know, permeable membranes. So the stuff stored inside diffuses outside from a higher concentration to a lower concentration till the diffusion is complete. So there's a bit of mass transfer here. So now, and okay, so what's the time now? All right, 3 minutes. Okay. So I'm going to take first sample, glutamine. So it's 100 by 25 by 3. 25 by 3. But this is grams. All right. So we'll just throw this out. And a little bit of contamination, but in a sense, the contamination in the sense the other amino acid is going to come. But I will have confidence interval. So the plus or minus 95%. So this is 25 by 2. 25 by 2. Okay. And this is not much of reaction here. About 25 by 2, it's 25 by 2. Okay, stir. What's the time now? So my next point would be 12. 9 would be my next point. So in the meantime, let's get some stirring done. One is out. One is out. In a sense, I'm not going to be measuring from one anymore, right? Because I've taken my measurement. So see, it's nice. It's the industrial setup. You want be measuring the previous samples being taken out. So you don't have an exact measure for okay. So second, so we just do again. Normally, when you withdraw a sample, okay. All right. So let's stir. Just do 2, and now start taking samples. Okay. So nice. Detect no color change. I see a capsule which is a little pink, I'm thinking, at the bottom with arginine. Arginine, yeah. Okay. This is. These enzymes are so fast. So this is 25 by 3/4. 25 3/4. Not taking completely 80% of a teaspoon. 25 by 2. So I did last time kinetics on all this, simulations, and match the results. Average, okay, you get the kinetic constant average, right? So this is 25 by 3. 25 by 3. Okay. So now stir, and wait for the next point. So it should be on the, what's 9, 12, 15, 12, 9, 6. Oh, I've already reached it. Well, just quick stirs for only these samples. And it's not quite a teaspoon, about 85% of a teaspoon. See how quickly, 25 grams. 25 grams. What am I making? Steroids. It's going to. The amino acids are kind of heavy. You see. So. This is actually dropping. 25.3. Twenty-five 3/4. 25 3/4. Okay, stir. What's the time now? So to go to 6. I'm in 6. Oh, 6 is right. 3. I have to go to 3. And then 0. Alright. Quickly. 3. Some mass transfer. These are all tablet making factories. Back in Bangalore, I had worked in a pharmaceutical company, Astrideal, for some 6 weeks, but they gave me a reference for six months. Yeah, because the project was kind of extensive. Okay, 3 minutes. All right, this is the right moment. I'll present some analysis. 25.3. I have a 2. Quite nice. Oh, it's let's say it's all completed. 25.5. So I'll just look at the structures again and then see if I can reach it's some form of conclusion. Or you'll have to wait for my and maybe if I give it to Mr. Sundar Pichai, he will attach it to this enzymes are really fast. I don't know about organic or metallic catalysts. So this is all right. This is close. So we'll take that's the bell going. Less than teaspoon. So this is 25 by 2. So 25 by 6. Let's take this out. Whatever it is, could be a gaseous reaction. Some of something could be coming out. The carbon dioxide. Am I friggin' breathing in carbon dioxide? Ammonia. I keep the door open for a bit. This is also 25 by 6. By 6, and the sampling measures approximately 85% of a teaspoon. So let me just see what all right. So glutamine, 2 CH2 groups, arginine, 3 CH2 groups, lysine, 4 CH2 groups. So some of it, So this and then again NH2, NH2 glutamine is NH3, NH2, 1 each, arginine, NH2, NH2, NH3. So this is 3, 1 each. This is NH2, NH3, NH3, 1 each. So there's a bit of a difference. So let me see, what am I getting? So here are my results. And so there's 4 CH2. This could be a good analysis for you people. And then I could give my worked out solution later. 2 CH2, 25 by 3, 25 3/4, 25, 25 by 3, 25. So 2 CH2 is more reactive actually. There's more of or there's a more I'll have to balance the reactions and then see how things work out and then hand them back to you. All right, maybe I'll ask Mrs. Sundar to attach my results, or in the meantime as a fun exercise, because it's exam time, right? You can yourself because I showed you once again, I showed you my results. You can yourself do simulations, analysis, calculate the K average from here, and then do a simulation with what you took. Just in Excel, it's pretty simple. 3-minute sampling times, and you'd have to do 1 minute because then it's more accurate. So you match it to 3 minute and that 369 to 15, and you there you go, you have yourself special chemical engineering a set of research results, an actual research paper, but it's mine. Research paper is mine, but fun time. All right, fun time, also work time. Work time. All right, thank you. Signing off, Gayatri B. Sitaram.